Okay, so objective 2 is really the second part of the lesson. It's the part about 8.4. So we did a little jump there. And the 8.2 and the 8.3, I'm not going to tackle until the very, very end of the chapter. I know it seems strange, but it's the order that makes sense to my brain, and that's what matters. Anyway, so in objective 2, we're multiplying and we're dividing rational expressions. You're going to see that this is almost the same thing as multiplying and dividing fractions. Multiplying fractions, very easy, top times top, bottom times bottom. But what do you have to do when you divide two fractions? You're supposed to take the second one, you flip it and you multiply it. So that's where the picture comes in there. With the blue angels, you've got some that are flipped over. You've got to flip them before you can multiply. Okay, so a rational number is 1, looks like a fraction. It's a ratio of two integers. So a rational expression is a ratio of two algebraic expressions. So I've got a whole bunch of them down there at the bottom. You've got x squared minus 4 over x plus 2. There's a rational expression. At the end, 1 divided by x plus 3. There's a rational expression. And that's what we're going to be working with for the rest of this unit. Maybe they're going to be just expressions, or maybe they're going to be equations where they might be equal to something on either side. So what we're going to be doing before we multiply and divide really is talk about simplifying these things. Okay, so a rational expression is said to be in simplest form if the top and the bottom don't have any common factors other than 1. The way that is said, like in mathematical terms, is that the numerator and the denominator contain no non-trivial common factors. Non-trivial means that it's not 1. So the trivial case is 1, so this means not 1, because of course it has common factor 1. Who cares about that? So take a look at this example right here. I've got x squared minus 4 divided by x plus 2. This is not in simplest form. You'll see why in just a minute. So on the top, it's the difference of two squares, which means, of course, you could factor it as x, there we go, x minus 2 times x plus 2. And I have a factor of x plus 2 on the bottom. I have a factor of x plus 2 on the top and x plus 2 on the bottom, so they get to divide out. Whenever these things cancel out, it's really that I'm left with the number 1 behind, because it's like the number 5 divided by 5, okay? So they're gone. And then finally, well, there you go, x minus 2 over 1, but you don't have to write over 1, so it's just x minus 2. And now it's in simplest form. So this works with every single number except for, this is kind of a little extension here, except for when x is equal to negative 2. Because if x was equal to negative 2, you'd have 0 on the bottom, the whole thing wouldn't be defined. And that'll come into play when we start graphing these things, and it's a lot of fun. I'm excited about it, yeah. Anyway, so this is just a page from your book here about simplifying radical expressions. If they have a common factor, you just cancel them out. Canceling them out means that they divide and give you 1. Okay, that's what it means. Down at the bottom there, if you see 15 over 65, if I have a fraction, I want to reduce it. Usually what you did is you thought of what went into the top and the bottom, you divided it out. So if you think of it as you factor the numbers and you cancel out each one of the factors, then it's exactly what we're doing whenever we do it with algebraic expressions. So like on the one at the very bottom, it has a factor of x plus 3 and x plus 3 in the bottom, and so they cancel out. When they cancel out, what are they equal to? Right. Okay. So here's what you do whenever you go to simplify rational expressions. The first one, step number 1, is to factor the top and the bottom. Okay? Factor the numerator and the denominator. Then once you have it factored, cancel anything that they have in common. Cancel out the factors that are in both the top and on the bottom. So let's give that a try right here. So I'm going to do the one on the, I'm just going to do them both. Okay, just because the first one's already factored for us, it's a piece of cake. Is there a common factor on the top and the bottom? Sure, there's the x plus 1. Get rid of it, x plus 1. And I'm left with x over x plus 3. And that's it. There are no other common factors. Now, a common mistake that some people will make is that they'll want to cross out the x's. Let me change colors here because this is going to be totally wrong. Make it in red. They'll want to cross out these x's and just be left with maybe a 1 over a 3 on the bottom. But I can't do that because x plus 3 is one whole factor. And I can't cancel out the individual term inside of it. So let me get rid of that there. And oh, really? Really? Okay, I'll fix it. Don't worry, I'll fix it. Nah. Yeah. Okay. So what do I do on number 2 first? It's an F word. It's factor. So look at the top. Factor out. It's just a binomial, and they have a common factor of 2x. So let's factor that out. 2x. Open up the parentheses. I'll have x plus 5 left over. Okay. Down at the bottom, open up 2 set of parentheses, and I got a 3x and an x probably, so I can get 3x squared. No, definitely. And here's a little tip. These things are all manufactured such that they're going to cancel something out. Since I have x plus 5 up here, this is probably going to factor as an x plus 5 in the bottom, and a 1 over here. Let's see if that works out. So on the outside I'd have 15, on the inside I'd have 1. Those add up to 16. So yep, see, little cheats like that will help you out. I can cancel the x plus 5s, and I'm left with 2x over 3x plus 1. Does anything else cancel? No. So determine what's wrong with this simplification, or I should say oversimplification. Because some of you are going to go, well, I don't know when I'm supposed to quit. I don't know when I'm supposed to quit simplifying. You quit simplifying when all the factors that are in common have canceled out. I don't get to cancel anything out but common factors. So let's see what this guy did. What? All right, what? Can you just cancel out these x squared terms? Answer is no, you can't. You can't because they're part of an entire expression. You can't cancel out individual terms in those expressions. If you're ever left in doubt, you could just plug in a number in the top and the bottom in this one and in the last one and see if they're the same. And here they're not. So the problem here is that this thing was already simplified. I know it was already simplified because there's no way x squared minus 2 is going to be a factor of the top. And you can't cancel out individual terms of expressions. So do not cancel individual terms of expressions. Yeah, you can only cancel out factors. Okay, that's important. Is that it on this one? Right. Yeah, okay, so stop here and then see you in the next video when we actually do some multiplying and dividing.